Right, guys. Check out if it comes to the first question here, it says that three solutions of strong electrolytes are being added. What is the pOH of the solution? So basically, first you need to realize that these are strong electrolytes. So HX will ionize completely as H plus and X minus. So that will include 25 into 0.1, correct? So this many millimoles. So that would get completely ionized into formation of 2.5 millimoles of H plus here. Similarly, if you take H2Y, it will give you 2H plus Y2 minus. So in this case, 2H plus includes 25 into zero point 0.1. That will also get completely ionized into 5 millimoles because 1 is giving 2, so that makes it 5. And the third one is uh, Z of OH twice, which will ionize as Z2 plus 2 OH minus. So this is zero point 0.1 normal into 50 ml. So let me write down what 50 ml, 50 into zero point 0.1 normal. So if you write the same thing in molarity, normality will convert into molarity by 2. Okay, so therefore it will be 50 into 0 0.1 by 2. That will be the number of millimoles. So which means this is also 2.5 millimoles, correct? So 2.5 millimoles. So 1 mole is giving 2 moles of OH minus. So that means I'll get 5 millimoles of OH minus. So these are the current situations of the solutions. Now in such case, what we can do is check out what is the total number of moles of H plus ions. Total number of moles include 2.5 plus 5. So total 7.5 millimoles. Okay, 7.5 millimoles. And total number of OH minus ions include 5 millimoles. Okay, so now if you have H plus OH minus giving H2O, so that includes 7.5 and 5. So 5 is less in quantity, so it is limiting reagent. So 2.5 millimoles will be left over, right? And the H plus calculation should be on the basis of whatever is the leftover amount. So 2.5 millimoles leftover divided by total volume. Notice the total volume 25, 25 and 50. So that makes it 100 ml. So 2.5 by 100 ml. So this much is the molarity. So pH will be equal to 25 by 1000. Sorry, minus log of 25 by 1000. So which makes it 3 minus log 25. Log 25 is 5 square, which is equal to 3 minus 2 into 0 0.7. So which is 3 minus 1.4, which is 1.6. So pH is 1.6. So that make pOH as 14 minus 1.6. So which is 12.4. So that is the pOH formation. So please go through it once. If you have any doubt here, you can ask me. All good? Start solving the second one. All right. All right. Let's see. See, ammonia is titrated against HNO3. What would be the difference? So basically, you have an ammonia and you are titrating that with HNO3. Okay. What is the difference of pOH between 1 by 4 and 3 by 4 stages of neutralization? So what does this mean? Let's see. Suppose I have ammonia, got it, aqueous, and sorry, treating with HNO3. So we know that this will become ammonium nitrate. This is the product you will get. Got it. So here I should have zero point 0.1 molar into certain volume here, and this has to be zero point 0.1 molar into volume here. Got it. Obviously, because the concentrations are same, we expect for neutralization same amount of volume should be used for a complete neutralization, I'm saying. But now what is being asked is what would be the difference in pH between 1/4 of the stage and 3/4 of the stage, which means when 1/4 of this is consumed and when 3/4 of this is consumed. Ammonia, this is always limiting reagent. Keep that in mind, because in titration, you are using this strong acid here. Here using strong acid HNO3, and then you are titrating that with ammonia here. Okay. So the composition of ammonia is always in a larger amount. So I can do it like this, that it is zero point 0.1 into V moles. Out of that, X moles have been consumed. So that means X moles of ammonia should be formed. And X is basically 1/4 of the initial amount. So 1/4 if it is consumed, 1/4 of zero point 0.1 into V. Okay. So which means 0.1 V minus 0.1 V by 4, and here it is 0.1 V by 4, which makes it this as 0.3 V, okay, or 0.3 V by 4, and this is 0.1 V by 4. So these are basically the concentration number of moles for ammonia and its salt. This is always limiting, which leaves us that there is a buffer solution forming here. So when this is a buffer, how much will be the pOH? The formula is for a basic buffer. So pKb plus log of salt by base concentration. So let us put this as pOH1, which is equal to pKb plus log of salt, which is 0.1 V by 4 into this is 0.3 V by 4. So which makes it pKb plus log of 1 by 3. This is first case. Next one is POH2. POH2 will be equal to pKb plus log of, now listen up, I'm directly writing it because I think you should understand the case. If this is 3 by 4, that means now the salt becomes 3/4 of it and the base becomes 1/4 of it. So now it will be reverse of it. So basically now it will become 3 by 1. Correct? So now it will become 3 by 1. So what is being asked is the difference in the pOH in both the cases. So pOH1 minus pOH2. So that is delta of pOH. So which is equal to pKb will get cancelled and I'll get this as log of 1 by 3 minus of log of 3 by 1. Okay. So that I can write it as, 2 log 1 by 3. You can take it as a mod difference here. So that makes it minus 2 into 0.48, which is the log form. So 16, 4 to the 8, 9. So how much we are getting? 0.96, right? So that is the difference you will get. Or I think here the question is more to do with the log terms here. So what do we get here? 2 log 3. So that should be your answer. Please go through it once. If there is any problem, you can ask me. Everybody good with this question? Samyak, Pratisha, any doubt here?
No, sir.
Great. Pratisha, Adhyat, any doubt here, beta?
No, sir.
Great. Now, everybody try the eighth one. See, calcium lactate is a salt of organic compound coming from weak organic acid and a strong base. So, this is a salt coming from weak acid and strong base. So when you have a weak acid and strong base combinations, we know that it is the uh, base, strong base, which will dominate, and overall solution will appear basic. I mean, it will have more OH minus concentration. Now, in this case, the weak acid is giving a conjugate base, which is lactic, which is LAC minus. Okay, so I have this LAC minus plus H2O, which will be hydrolyzing to form LaCH plus OH minus. And for this, the hydrolysis constant is KH. This is the hydrolysis constant. Got it? And initially, if the concentration is C naught here, and this will become C naught minus C naught H, which is the hydrolysis constant, sorry, which is the degree of hydrolysis. This will be C naught H, but the POH is already been given how much it is. So I can write simply this as 10 raised to power of minus 5.6. So that will be the OH minus concentration. Okay, just a second. That will be the OH minus concentration. And now, using this fundamental, we can write KH will be equal to C naught H into 10 raised to power of minus 5.6 divided by C naught minus C naught H. And you know that KH value can be always written as KW by KA. So this much you should know, that KH can be written as KW by KA. You don't have to go through the derivation. If you know that, that should be good enough. So if C naught is the initial concentration, one C naught will get cancelled here anyway. So C naught will not be there in this term. So you'll have H here. So H into 10 raised to power of minus 5.6, that divided by 1 minus H. So that is equal to, and you know that what is the pK value is given here. Sorry, that is what we need to calculate. What is the pK value here? Okay, H value is already given to us. So therefore it will be Kw by Ka. So I can write this as Ka is equal to Kw into 1 minus H by H into 1 by or 10 raised to power of 5.6. Correct? And now if I take the pK value here, so pK is equal to pKw plus, sorry, minus pKw minus log of 1 minus H by H minus log of 10 raised to power of 5.6. Okay, so this is what we can write. So pKw value is 14 minus log of, how much is this value? 1 minus, this was 90% ionized. So 1 minus 0.9. As per the question, I think it is 90%. Yeah, 90%. And this I can write it as plus log of 10 raised to power of minus 5.6. So which is equal to 14 minus log of, how much is this value going to be? This is 0.1 by 0.9. So that plus, and log of this value will be 5 point, sorry, minus 5.6 here. So I can just simply write it as minus 5.6, which is equal to 14 minus log of 1 by 3 minus 5.6. So that is equal to 19.6 plus log of 3. Got it? Sorry, not 19. I have to subtract that. So that makes it uh, 8.4 8.4 plus log of 3. So 8.4 plus 0.48. So that makes 8.88. So that should be the pK value approximately. Okay. Or simply you can check out whichever is the possible value that is matching up here. Got it?
Sir,
हाँ बेटा. Let's see how to solve this one. The degree of dissociation of weak acid in the presence of strong acid is given. Okay. So you start like this. Ha is offering to become H plus and A minus. Okay. Initial concentration is 0.1. Correct. Now, already Hb is a strong base, so there is already 0.1 concentration present in the start. Okay, so which means it will be 0.1 minus 0.1 alpha. This will be 0.1 plus 0.1 alpha, and this will be 0.1 alpha. Correct? This is the amount dissociated. So now Ka value will be equal to H plus concentration into A minus concentration upon Ha concentration, which I can write it as 0.1 plus 0.1 alpha into 0.1 alpha divided by 0.1 minus 0.1 alpha. Okay. So based on the given equation, it is clear that this 0.1 alpha has to be very, very small because of the common ion effect. And here also the 0.1 alpha can be ignored. So which means Ka value, which is given as 10 raised to power of minus 6, will be equal to 0.1 into alpha by 0.1. Okay, clear? Sorry, one more 0.1. Yeah. So therefore, alpha will be equal to 10 raised to power of minus 5. So this much will be the alpha value. Clear? That is the degree of dissociation asked. Right, Sudiksha, very good. I hope all of you got that. Now let's go to the question number 12. Please try it out once. I'll give a minute's time, then we'll discuss again. Okay. We are talking about a salt AgA solid which will ionize into Ag plus A minus. And this A minus plus, we are keeping this, what do you say, the pH of the solution, correct, of the salt solution is found to be 9. So that means this Ha plus, because it is a monobasic acid, right? So we can expect that this H plus, as it reacts with it, it can form Ha here, okay? And this Ksp value is given, or rather, that is what we need to find. And Ka value is given, which is 10 raised to power of minus 10. Now, adding these two, we will get the overall reaction, which is Aga plus H plus is going to give us Ag, uh, Ag plus Ha. Okay. And Ksp value will be equal to Ksp divided by Ka. Because for this equilibrium, it is actually 1 by Ka, what we need to know. So it is 1 by 10, 10 raised to the power of minus 10. So from here, I can say that Ag plus concentration. Okay. Now see, pH of this saturated solution of this monobasic acid given is 9. Okay. If this is, if I can say that 10 raised, this H plus concentration in this case is given as 9 here, which means the OH minus concentration, I can say, one second, silver salt of monobasic acid, Ha. Monobasic acid is given as Ha here. K value is given. Oh, Ag plus concentration into Ha concentration divided by H plus concentration. That should be equal to Ksp by Ka. Okay, just a second. Right, let me tell you again. See, think this way. AGA is the one which is giving out the dissociation of Ag plus and A minus. But what is happening is this A minus will hydrolyze because it is coming from a very weak acid. It will undergo hydrolysis and it will give you Ha and OH minus. And from there, I can say pH value of a salt hydrolysis. We know that because it is coming from a weak acid. For that, the pH formula is this one. So use that half of 14 plus 10 plus log of C naught. And from there, we'll get what is the C naught value. That is the concentration of A minus how much it is. So you know that A minus concentration is 10 raised to power of minus 6. And beforehand, there is nothing like Ag plus or anything present. So that will be the same concentration of Ag plus as well. Hence, Ksp will be equal to 10 raised to power of minus 6 into 10 raised to power of minus 6, which is equal to 10 raised to power of minus 12. So that will be the Ksp value. Clear? So please do check now. I hope you guys understood. We have a Ksp value for the first case, and then we have a Kc value for the second case here. So what you can do here is to understand that the solubility, okay, overall solubility S of ZnOH twice, because it is ionizing as Zn2 plus also, and it is ionizing as this one also. So I can say whatever be the concentration of Zn2 plus it is generating, plus whatever be the concentration of ZnOH4 2 minus it is generating. That will be the total solubility. Correct? So to get the total, to get the concentration terms here, the first case I can say Ksp is equal to Zn2 plus concentration into OH minus concentration square. And in the second case, Kc can be written as ZnOH4 2 minus concentration divided by OH minus whole square. So from here I can say Zn2 plus concentration is equal to Ksp divided by OH minus whole square. And in the second case, Zn OH4 2 minus can be written as Kc into OH minus square. OH minus square. Okay. So now, if you put them back here, so solubility will be equal to Zn2 plus concentration, which is Ksp divided by OH minus square, plus second case, this can be written as Kc into OH minus whole square. Got it? And we need to check out because now we got an equation solely on the basis of OH minus. We can say that the differential part of solubility with respect to OH minus has to be 0 at a minimum. So therefore, if I differentiate this, what would I get? I'll get Ksp by, okay, so 2 times of Ksp by, oh sorry, minus 2 times of Ksp by OH raised to power of uh, 3, and that plus 2 times of Kc into OH minus, that is equal to 0. Got it? So now if you multiply this, what do I, if you take it to the other side, so we will get 2 will get cancelled. So we'll get Ksp uh, divided into OH minus whole raised to power of 4 plus Kc with minus is equal to 0. So therefore Ksp by OH minus raised to power of 4 is equal to Kc, or OH minus whole raised to power of 4 is equal to Ksp by Kc. So you can see OH minus concentration raised to power of 4 is equal to Ksp value, we got it as 10 raised to power of minus 17, right? Divided by 0.1. So that makes it 10 raised to power of minus 16. So OH minus concentration is equal to 10 raised to power of minus 4. So POH we are getting it as 4, so which make pH is equal to 10. This is a very standard JE question. So please check it out how to solve it. If there is any problem in understanding, just let me know. I can explain that once again. How many ammonia moles to be added for this AgNO3 in order to reduce Ag plus concentration, to reduce the Ag plus concentration to this amount? Okay. So basically we have AgNO3 plus NH3 of 2 moles here. That will give us AgNH3 twice plus NO3 minus. So now you can see this is 2 liters into 0.8, and let's say we have X moles here and this was not there. So we have total of 1.6 moles here, X moles here, and nothing here. Got it? I mean, sorry, initially we have this much moles. So now what would happen from this 1.6, some X amount will be, some Y amount will be consumed here. So this will be X minus 2Y amount will be consumed here to form this as 2Y and 2Y here. Got it? Now if I remove this NO3 minus, that will simply become the Kf value. You know, Kf value is this Ag plus 2NH3 formation ones. So it is in equilibrium with, got it? Ag NH3 twice plus. This is the Kf value. 1 minute. So Kf will be equal to, okay, welcome. So 2y divided by x minus 2y into 1.6 minus y. Correct. This is the value we have. But already you can see Ag plus concentration is given. This much is given. So which means most of the Ag plus has been already consumed into this product form. So y value here, got it? Sorry, this is y only, not 2y. Should be y. Yeah. Sorry. So this will be square of it. So Kf will be equal to y. Because Kf value is very high, I can say that most of the content will get converted into product. So y value will be equal to 1.6. Okay. Y value will be equal to 1.6 divided by, okay, x minus 2y. So 2y is x minus 2y is, 3.2. So that into Ag plus concentration. Ag plus concentration is already given as 5 into 10 raised to power of minus 8. Now that will be equal to Kf. So Kf value is 10 raised to power of 8. Done? So you just got to use this value now. So 1.6 is equal to x minus 3.2 square. This should be square here. Okay. 1.6, sorry, square should be here. I made a mistake there. Yeah. So square here. So that should be equal to, so this 10 raised to power of minus 8 will get cancelled. So 1.6 by 5. Got it? Uh, 2 into 0.8, 1.6. Yeah. So all of that is correct. So you solve it for x, that should come out as 4 now. Okay. Let me see if why that 5 is there. 5 into 10 raised to power of minus 8. Concentration should be 1.6 moles x minus 2 times of 1.6. Oh yeah, I need to multiply that with 2, we have to divide it by 2 as well, because that is the volume which we have. Forgot to mention the volume as well. So you have to write that in terms of volume as well. So this one should be by 2 by 2 by 2 here. Okay. So that 4 term will come in the numerator here. So that's how you can get x is equal to 4. Done. Please check. All good. So if you see these questions, it is been given that we have equal volume of these two being given. Okay. So once you add both of them, you will have 0.0 AgNO3, or I'll simply take it as Ag plus. Okay. Ag plus HCl. If you compare these two, so this will be 0.02 into V, 0.02 into V. Correct. So that makes it AgCN plus H plus here. Okay, or I can write it as HCN amount here given, so that total amount will be consumed. So you can see that the amount of Ag plus and Cn minus are equal, and if you notice that we will not have any Ag plus left or HCN left, so we will have 0.02 V moles of AgCN, correct? And how much amount of H plus you will have? You'll have 0.02 V moles of H plus ions present in the solution. Got it? These are number of moles, millimoles. Now, if I write this AgCN, because almost all of the Ag plus and HCN is consumed, once it becomes AgCN, again it will ionize into Ag plus and Cn minus with a equilibrium constant of Ksp. So Ksp can be written as Ag plus and Cl minus concentration. So Ksp value is given as 4 into 10 raised to power of minus 6, which is equal to Ag plus and Cn minus concentration will be almost the same. So S square is equal to 4 into 10 raised to power of minus 6. So S will be equal to 2 into 10 raised to power of minus 3. So that will be the concentration. Got it? One second. Ag plus ions in the final. Oh, one minute. I made something wrong here. It is affected by presence of common ion, hydrolysis of ions in container equal volume of 0.02 molar and 0.02 HNO3 is mixed. Okay, got it. So which means this Cn minus which is there, okay. So whatever the Cn minus which is forming here, correct, that will get affected by the hydrolysis of H plus. So that will become HCN in this case. So that will be equal to 1 by Ka value here. So add both of them. So then we will have this as AgCN, right, plus H plus is ionizing into Ag plus HCN. So this is the amount that will be left over here. So HCN will start forming again once because in the presence of this H plus concentration, which is of 0.02 V moles here, this many moles are present, to which hydrolysis will be acting. Okay. So in that case, I can say this H plus will almost remain the same as 0.02 V here. And if you compare the Ag plus and Cl minus concentration, Ag plus and HCN concentration, so I can say this is something like S nu and S nu, because both of them will be forming in the same amount. Okay, because initially they have been consumed already. Got it? So in that case, this will be Ksp divided by Ka. So I can say S nu square divided by H plus. H plus is 0.02 V by 2V, because that will be the concentration of H plus, which is equal to Ksp by Ka. Ksp value is how much? Ksp value is 4 into 10 raised to power of minus 16 divided by Ka value, which is 4 into 10 raised to power of minus 10. Okay. So from here, S nu square, which is the Ag plus concentration, will be, everything will get cancelled here. So this will be 10 raised to power of minus 6 into 0.01. So which will be 10 raised to power of minus 8. So S nu, which is equal to 10 raised to power of minus 4, will be Ag plus concentration. So the first case is 10 raised to power of minus 4 concentration. Okay. So please notice this case once, everybody. Check if you have understood that or not. No, Samik, I hope you got the point. Y21 is D,
Yes, sir, I did calculation mistake.
right? No worries. Now, pH of the final solution will be how much? Okay, pH of the final solution, uh, if you could see what is the solution we are here. So, because this is the H plus that will be present in here, so approximately you will see the OH minus concentration, sorry, the H plus concentration will be equal to 0.02 divided by 2. So which is 10 raised to power of minus 2. So pH value will be approximately 2 here. Okay. Next, concentration of Cn minus. How much will be the Cn minus concentration? Now, Cn minus will be almost lost. Now, what you can do, you know the Ag plus concentration now, correct? Use that to figure out the Cn minus concentration using Ksp. So Ksp is equal to Ag plus concentration into Cn minus concentration. So from there, Cn minus concentration is equal to Ksp, and Ksp value we got here as 4 into 10 raised to power of minus 16 divided by Ag plus concentration. Okay, Ag plus concentration is 10 raised to power of minus 4. So which is equal to 4 into 10 raised to power of minus 10. So that will be the value, which is A here. Okay, clear? Everyone understood? I think the last answer you're getting it as C. Let me see if I messed up any values there. 4 into 10 raised to power of minus 16.
So last step.
Last step it is 10 raised to power of minus 12. Yeah, please check. Everybody got the idea how to do that? Right. For others, please check this question now. We have a buffer solution which is made out of ammonium sulfate and zero point 0.1 molar ammonia. X moles of this. So pKb value is given. So you know that this is a basic buffer. So POH, first check out what is POH. POH is 14 minus 9.26, right? So that comes to be approximately 4.74. So 4.74, and the formula what you would be writing is POH is equal to pKb plus log of salt ion concentration by base concentration. So POH is 4.74 is equal to 4.74 plus log of salt. And here salt is what I need to find out, which is the concentration C. I'll write it as concentration C of ammonium ions, that is NH4 plus ions, that divided by B, which is the number of moles of base. So which is 0.1 moles, sorry, 0.1 moles of ammonia into 100 ml of solution. Okay. So we do not have to worry about the volume because the volume term will anyway get cancelled. Hmm. So 0.1 moles. Now I can say concentration of NH4 plus, I mean number of moles of NH4 plus. Let me write on that number of moles. Number of moles of NH4 plus will be equal to, these two will get cancelled. So we'll have 0. So 10 raised to power of this 0.1 into 10 raised to power of 0, which is 1. Okay. So that is equal to, and a number of moles of NH4 plus will be equal to 0.1. Now, ammonium sulfate is ionizing to give 2 moles of NH4 plus and SO4 2 minus. Now, if this is 0.1 moles, then this has to be 0.05 moles. Correct? So that is what has been asked. What is the value of X? Clear, everyone? Right. Good. Check. Sorry. So basically, if you check out the steps given here, we know that H2CO3, let me put it as the equilibrium form as H plus and CO3 2 minus. That's how we can get carbonate. Okay. Because here Ka overall is given, I'm directly writing this part. Okay. So Ka overall given is 5 into 10 raised to power of minus 16 in this case. Okay. And now we can write the CO3 2 minus concentration here as Ka multiplied by H2CO3 concentration divided by H plus whole square concentration. Correct? And how do I find the CO3 2 minus? Now that is a important part we need to understand, because either of this metal ion, either it is Sr plus 2 or Mg plus 2 is what you will get. When do we have minimum pH? Minimum pH is when you have higher H plus concentration. To get higher H plus concentration, you should have lesser amount of CO3 2 minus. Now, out of the KSP values, if you notice, like for MgCO3 and SrCO3, now when the concentration of Sr plus 3 is higher, then the carbonate will be lesser, because this will be the first one which is supposed to get precipitated. In that case, we will have a lower amount of carbonate concentration. Hence, I can say that when Sr2 plus concentration is at 0.1 molar, then what will be the CO3 2 minus concentration? It will be equal to Ksp by Sr2 plus concentration, which the Ksp value given is 9 into 10 raised to power of minus 9 by Sr plus 3, which is 0.1. So 9 into 10 raised to power of minus 8 should be the concentration of carbonate. So at this concentration, what will be the H plus concentration? That will be the minimum pH or maximum H plus. So Ka into H2CO3 divided by CO3 2 minus. So that is equal to Ka value overall given is 5 into 10 raised to power of minus 16. H2CO3 concentration is given as 0.05. It is maintained at 0.05. Bicarbonate, which we learned, which we calculated as 9 into 10 raised to power of minus 8. This is what we have, correct? So this is coming as approximately 2.5 by 9 into 10 raised to power of minus 9. Okay. So 2.5 means approximately we are getting this as 3. I'll just put it as close to 3. Okay. Close to 3 into 10 raised to power of minus 10. Yeah. So which means the H plus concentration will be equal to approximately root 3 into 10 raised to power of minus 5. Okay. Root 3 means around 1.7 into 10 raised to power of minus 5. This is the first case beta. So, I mean, if you calculate the pH, what do I get? So pH will be equal to, oh, I need anyway pH, right? Sorry. So I can directly use that here. So pH is equal to 5 minus, log of 3 raised to power of half. Correct. So that is equal to 5 minus um, log of 3 half into 0.48. So that is coming approximately 4.8. Got it? Clear, everybody? This is the first case beta. Now what about the second case? The second case is when the pH is highest. Okay. So for that, now you know that what should be the carbonate concentration. In that case, we need to make sure that the H plus I mean the Mg2 plus concentration, because At this point, you'll have the maximum amount of carbonate ion. So which means this is the concentration of Mg2 plus we need to maintain. So you can see Mg2 plus concentration into OH CO3 2 minus concentration. That will give you its Ksp, and we need to maintain Mg2 plus concentration at 0.01. That into CO3 2 minus will give us Ksp value. So Ksp value for that is given as 2.5 into 10 raised to power of minus 7. So at this point, carbonate concentration should be 2.5 into 10 raised to power of minus 7 by 0.01. So which means 2.5 into 10 raised to power of minus 5. When carbonate is of this high concentration, then the H plus amount will be less. Because ये ज़्यादा रहेगा तो reaction will push in the backward direction and H plus concentration will be less. Now let us put back to the same equation. So H plus square is equal to Ka multiplied by H2CO3 concentration divided by CO3 2 minus concentration. So Ka value here, we learned it as 5 into 10 raised to power of minus 16 and into H2CO3 is 0.05 divided by 2.5 into 10 raised to power of minus 5. Correct? So I think here it is maintaining the 2.5 will get cancelled. So what do we have? 10 raised to power of minus 12. So H plus concentration will be equal to 10 raised to power of minus 6. So pH has to be 6. So you can see pH minimum we got it as 4.8. pH max we got it as 6. Okay. So this is how you need to solve it. So please do check. If anybody has a doubt, they can ask me now.